Hello, today I'll walk you through my machine learning project, Anomaly Detection in Enterprise Communication Logs. This system is designed to help identify suspicious communication patterns in enterprise environments to catch potential threats early and reduce alert fatigue for security teams. The task analysis reveals that manual review of enterprise logs is both slow and prone to errors. Our goal is to identify unusual patterns in communication logs, addressing the challenges of high volume, subtle anomalies, and alert fatigue. By leveraging machine learning, we aim to flag only suspicious entries and provide clear prioritization. The problem we're addressing is the overwhelming volume of communication logs, emails, messages, and system access records that security analysts must review manually. This process is time-consuming, error-prone, and often leads to missed threats or false alarms. The core task is identifying abnormal patterns in logs, such as unusual message frequencies, off-hours communication, or unknown IPs. The pain points are scale, subtlety of threats, and analyst fatigue. For task analysis, I found that machine learning can simplify this flow by surfacing only high-risk, unusual activity. This helps analysts focus their attention where it's most needed. In designing the user experience, we focus on a seamless user flow where analysts can view an anomaly dashboard with flagged log entries. Analysts provide feedback on false positives and valid cases, enhancing transparency by explaining anomaly scores and using confidence scores to indicate model certainty. The user experience is designed with the analyst in mind. Users interact with a dashboard that shows flagged log entries with risk scores, timestamps, and explanation overlays. Feedback loops are built in. Analysts can mark entries as true or false positives, and that input is used to periodically retrain the model. To maintain trust, the system provides transparency. Each anomaly score is accompanied by an explanation, such as, spike in message count from an unknown sender at 3 a.m. Uncertainty is also communicated via confidence bands or labels like, high, medium, or low confidence, so users are aware of how reliable the prediction is. Privacy is paramount, as communication logs may contain sensitive user data. We adhere to laws like GDPR and CCPA, ensuring obligations such as anonymizing sensitive fields, minimizing data, and maintaining auditability, while upholding the right to explanation and contesting decisions. Since we're analyzing potentially sensitive log data, like usernames, IP addresses, or message content, privacy is critical. We address this by anonymizing sensitive fields and minimizing the amount of data we store. GDPR and CCPA both apply, especially if employees are located in Europe or California. That means we must provide transparency about automated decisions and offer users the right to access or delete their data. The system is also designed to retain only what's necessary and includes audit logging for data access events. Ethical considerations are crucial, particularly in addressing bias risks like overflagging certain roles. We strive for fairness by debiasing datasets and removing sensitive attributes, ensuring accountability through human-in-the-loop reviews, and maintaining transparency throughout the process. Bias is a real risk in anomaly detection. For example, users who work non-traditional hours, like night shift workers or remote employees, might get flagged unfairly. To address this, we ensure fairness by debiasing the dataset, removing sensitive features, and conducting regular bias audits. We maintain accountability with a human-in-the-loop approach. Flagged anomalies are reviewed by analysts, not acted on automatically. Finally, we ensure transparency by explaining how scores are calculated and by allowing users to contest or provide feedback on decisions made by the system. In our demo preview, we will showcase sample communication logs with highlighted anomalies and risk scores. Analysts can mark entries as valid or false positives, with optional SHAP or heatmap visualizations to enhance interpretability. The final model uses unsupervised learning, such as isolation forest or autoencoder, to identify unusual communication behaviors. In the demo, I'll show a sample log, the assigned risk score, and a simple SHAP-like visualization explaining why it was flagged. The analyst can then mark that log entry as suspicious or safe, helping the system improve over time. This approach makes anomaly detection faster, more accurate, and more scalable for modern enterprises.